So this is the August 2018 Structural Modeling Project video conference. Today we have Ed Carroll presenting on model-based engineering. And I'm just going to turn it over to Ed and let him walk through the material he'd like to present. Ed, it's yours.
So, excuse me, how many of you were at the INCOSE International Symposium? Any of you?
I wasn't there.
Nope.
Okay, well, that's not surprising. INCOSE is the international, I can't think of it. Anyway, it's the International Association for System Engineers, and you're system scientists. So sometimes they cross-pollinate, sometimes they don't. This manifesto was presented there, which is why I was asking. So I will retread what we presented then. So to begin with, this manifesto started out in at a conference from the International Federation of Systems Research, IFSR, of which ISS and INCOSE and about 45 other international associations are affiliated to it. And it drew my attention because as a research analyst in in engineering methods, and particularly systems engineering, and a system scientist, I was interested in where I can publish and put research and that kind of things. This particular conference was called a conversation. And the reason they made that distinction was because it's the concept of a small group of people coming together for about a week, and you stay together in that small group and you spend the entire week talking about your topics of interest, which appealed to me because it actually, in that amount of time, one can actually get very deep into a particular topic, which is what we did. So I submitted a topic and was accepted, and so I led a workshop in Linz, Austria, for a week-long conversation on data-driven engineering. I handpicked the participants from very senior people and leaders in system engineering from across the country, and I was successful in getting 8 of them to come to Austria to participate in this week-long conversation. I particularly selected people that had diverse perspectives on the topic and where we're trying to go, where the industry is trying to go with it. For example, I come out of software. I've used software and model-driven software engineering techniques for 30 years. I've built systems that are small and large, and hardware and software combined for that period of time in a variety of different types of things, from warehouse systems to defense systems to general business type of applications. Nancy Hayden is particularly involved in autonomous systems and artificial intelligence, which is, in my view, going to drive some major paradigm changes in how we engineer systems. Sharon Troth is what I would call the consummate model-based system engineer. She's a woman who has led model-based systems engineering for a good 25 years at Sandia. Dana Grisham is leading Sandia's data strategy, data architecture, and brings the concept of that fundamental need and place to the industry, or to what Sandia is doing. Chris Schreiber is a system engineering manager. So and responsible for implementing model-based system engineering through Lockheed Martin Space Systems. So he brings that management perspective. Bill Schindel is a consultant who has been leading the charge on pattern-based model development and the concept around the smallest model. You can see my hands. I'm an engineer. I have to talk with hands. And then Frank Salvatore provides two perspectives. He was a contractor for the Department of Defense System Engineering, deeply involved in their digital engineering initiative, as well as being deeply involved in NCOSI's efforts for digital artifacts and data analysis, decision analysis. Elliot Rich is an academic who brought to the table the idea or the concepts around how to model using systems dynamic and simulation. And Steve Jenkins is a principal at Jet Propulsion Laboratories. He is probably the leading expert, as far as I'm aware, in the industry in ontologies. And Anne O'Neill is a consultant and former chief system engineer for the New York City Transit Authority, and is a consultant in organizational transformation. So how do you move into a new paradigm? And if you're not deeply involved in engineering and system engineering, then I should say that the transition to a model-based engineering approach is a paradigm shift for the industry, and we're struggling with it, which is why we wanted to have this conversation. The end of that week, yeah.
Ed, can I say, just to give you a little background, Peter and I have attended a few conversations before, so
cool.
And we usually would have been at the IS, but not this year, just so that you don't need to explain too much of the background there, just so you can take off on the details.
Well, it's a good segue. I was just about to say that the end result of that week's conversation was this manifesto. We didn't really intend to build a manifesto in the outset. It evolved throughout the week. The week's conversations turned into a conversation about, well, okay, we all agree with this is something we should be doing. How do we get the industry to make that shift and move that transformation? And so we talked through all the different parameters and issues involved in doing models and building models and doing it well and that kind of stuff. And in the end, it seemed a logical conclusion that, well, let's just package these concepts, these 40-some charts that were posted all over the room, and put them into this manifesto. And this is the end result that it came out to. It's a couple things I would say before we launch into it itself is the first of all, on the value statements, the little white line underneath there where we value the items on the right, but not to the sacrifice of the items on the left, is an important key. We value building model artifacts. We value independence in developing models. We value flexibility in how we design systems, and we value model creation. But we think that the items on the left, information, integration, expressiveness with rigor, model usage, are more important. And so that's the main message to try to convey there. The principles are those kinds of things that we think promote good, best model development. And with the in our view, the end goal being fully integrated digital models that will tell us everything we need to know about a system to be designed. And then the last point I'll make before we launch into this is that although we were a bunch of system engineers and we came at the problem from system engineering perspective, we took the word system out of the title because we think that these principles apply to any kind of digital engineering model. And so with that, I'm bringing this manifesto to this group with the idea of talking through any and each of these values and principles, try to see if they hold water. So now I would encourage any questions.
Well, thank you, Ed. That's
I'm presuming you're reading it while I'm talking.
it's a lot. There is a lot of information on these charts, and as when I first scanned it, it seemed to be straightforward. And then I scanned it again and looked at it again, and it's a lot of very interesting things there. Just in general, though, I like the format. There's a lot of it's densely packed on this slide, and where you have the 4 items at the top: information over artifacts, integration over independence. Those are, I think, very good categories that you're starting to establish, to look at. And when I read those and I thought about them a little bit, I thought what would really help me understand a little bit more about what's going on here, and especially the value part, would be to have a little bit more points in the range. If you think like information over artifacts, if that's a category range, I have 2 endpoints on a range. Information on one endpoint, artifacts on the other endpoint. Is there anything in between? Is there a graded range in there? And so if there was, then that would help establish the context for those 2 endpoints. And so that was just my kind of first impression on that when I was looking at it. And the other part, going through the principles, there's, I have 100 questions about different specific aspects of this, and I don't really want to dominate the conversation, so I'll just say my first highest point of interest is in the second one, where it talks about the underlying nature of semantics, and but I'll let other people bring their anything they'd like to talk about forward.
So you asked me several questions there. So let's go back up to the value statement. I don't look at those as categories. I look at those values. The notions, there's a notion in each of them that is worth conveying. So before I get into each one of them, as a group or as a term, what we want is to do 2 things. The first is to simply get the conversation going. So we feel that if we can get people talking about how do they transform to a model-based paradigm, engineering paradigm, then the right things will come out, right? The right ways to build models, the right way to design systems, and that kind of stuff. The second thought is that all of this, the title, the values, and the principles are meant to be inclusive, not exclusive. For example, in my world, there's a lot of discussion about the term model-based, ... There is model-based engineering, model-based systems engineering, model-based engineering environment, model-based enterprise, and all these terms. And each one of those is meant to be what I would call an exclusionary term, to find a group of people that's exclusion of others. Our title is meant to be inclusive. We limited it to the word engineering because we were trying to include all the engineering disciplines, not just systems or CAD or mechanical or electrical or even physics algorithms and models of that type. We're trying to be inclusive of all of those. We think that these values and principles apply to any of those kinds of modeling-based paradigms. So for example, in the first value statement, information over artifacts, one of the primary values of models over the more traditional way of building systems with two-dimensional drawings and textual documents is that in a model, the information contained in both of those drawings and documents is combined into the model itself. And in addition to that combination, there is other information that you cannot define or store in a textual document or in a drawing itself only. Things like behavior and parametrics and interactions and integration points between the drawings and the textual documents and decision points along the way. That combination of all those kinds of things adds up to information. And it's that information context of a model that we think is more important than an output artifact itself. So an artifact would be a system requirements document or an engineering drawing of some kind or a change design document or a set of documents of that sort of thing. Those are artifacts. And those are important. You have to do them. We will all be doing them for a long time. But it's that collective information in the model that we feel is more important. And that's what makes models more valuable than the artifacts itself. Does that make sense?
It does, Ed. I think actually when I first read that, it just popped into my head. You know, when I read that first statement, it says information over artifacts. I said, well, what about information artifacts? And what about information about artifacts? And so essentially what we have, what I hear you saying is, well, actually we value executable information over static information, and we value all types of information over monolithic artifacts. And so that, you know, and that was kind of the range that I was thinking about. But when
you have to keep this in an engineering context. The example is the systems that I work with at Sandia now, or that we build at Sandia, are if you're in the textual documents are in the range of 1,000 pages each, and there's hundreds of the documents involved in defining a system. And I challenge anybody to think that they have any of that information collectively integrated and interrelatable when it's in that form. But in a digital model, I can search that information. I can relate that information to other bits of information, and I can pull in on a thread of one point, and I can pull all the information related to that point all the way through this model for this highly complex system. You can't do that in a textual document. And so it's that kind of combination of executable or dynamic information that we're after, in contrast to the artifacts.
The static artifacts.
I think what Joe is pointing out is that the digital form is also an artifact. So there's a more subtle distinction there that you're making between, you know, whether it's actionable, whether it's accessible, whether it's informative, searchable, you know, dynamic, interactive, so it's really you're not counterposing information over artifacts. You're not wanting the informativeness to be lost in the artifaction or something.
Yes, yes. So a lot of these points, the values and the principles, are trying to correct some ill. And so what happens a lot in the industry is that we we get wrapped up in developing a requirements document to the exclusion of everything else. And we finish that 1,000-page document and we give it to the customer and say, we have delivered, but we haven't built anything. We just defined a 1,000-page document, an artifact. And the information that goes way beyond that artifact is in what you're describing as the digital model, in the way you're describing it. So yes.
Did you share these slides? And is it just this one, or are there more? Because I'd like to stare at it more closely and mark it up.
Feel free to stare at it closely and mark it up. The manifesto itself is embodied in this one slide. I have 2 other slides, but they're more about the conversation.
Okay.
Because as an analyst, I work with a group of analysts, and I was going back to them to tell them that, or try to encourage them to consider the conversation model more. So the other 2 slides are irrelevant to this conversation.
Yeah. Okay. I think we would be interested.
I have a copy of the slide. Do you care?
Yes, please. Could you share that? Yeah. Peter is the current president of ISSS, and we have spoken quite a bit about the conversation model. We actually have held a few mini conversations as well. Have you been involved in Rick Dove's, what does he call them? System summits?
Yes.
Yeah.
I have. I've spoken at the last 2 of them.
Yeah. So yeah, I tried to get him interested in the conversation model, but he had a particular vision. I don't know. They're both useful, interesting, unconference type experiments. The conversation we have found very helpful for exactly what you said, the ability to really focus and get an interesting group together. And I'm impressed by the group of people that you have here. I'm sorry we missed this last year.
Thank you.
So when you say the items on the left and the items on the right, I'm not sure which is the left and the right.
So can you see my cursor? I'm not driving. I guess not. So the items on the left, I'm referring to the 4 value statements: information over artifacts, information's on the left, artifacts on the right. Integration over independence, expressiveness with rigor over flexibility, model usage over model creation.
Okay. All right.
Ed, do you care if I distribute the slides to the list?
I'm sorry, I wasn't able to understand that question.
You sent me the 3 slides. I didn't distribute them to the list because I didn't have your permission to do so. Do you care if I do that?
That'll be fine. Yes, please do that.
All right.
Particularly the manifesto. I'm wondering if I were to pick up the manifesto out of context, I wouldn't know what to make of it. It's a pretty dense slide. If I had the others, maybe it would make more sense. I'm not sure.
A little bit more context probably would help. So the next point that I was interested in was the idea, the underlying nature of semantics, of the essential information we seek to discover and produce is invariant. And so that to me was kind of very interesting. And I kind of thought, okay, what is this? What is this really driving at?
Okay, so there's a number of concepts in that context. So what we're talking about, so there's a lot of information on a highly complex model. There's structures, there's language, and between models, particularly one vendor or one contractor, one modeler, et cetera, can say the same thing in a lot of different ways. But regardless of that, there's also an underlying structure to that information. So if you're not in that area of stuff, I think this group probably understands what an ontology is, right? So in the model development world, there is a very specific ontology, or should be an ontology, underlying your models. What we're trying to get to is the notion of an integrated digital description of a system. Description meaning encompassing everything from the textual description down to the spatial and the electrical and everything else. So the whole context of it, right? If you have an ontology that defines that underlying semantics of the multiple models that go up into a complex system, then your models will be integratable. Without that underlying semantic ontology, you have no way of integrating your models. And so that's where we're driving to this. And what we're suggesting here is that semantics of that model, that underlying ontology, doesn't change because of all independently of any of the stuff above it, and any of the way you're using the information or the information you're contained in that model. So for example, in any engineering system, you have requirements, you have documents, you have these underlying ontological elements. Those things stay invariant between models.
Okay.
And across models.
Okay. That's interesting from a number of standpoints. We talked about ontologies, and I've been working, Mary and I have been working on the idea that a system is a relationship associated with a collection of objects. And just this last week became aware of an ontology, an executable ontology that was called Gellish. It's basically a set of relationships that are mapped over objects. And so I was looking at that, and I think it's a very good way to think about things from an executable, more formal logic type of approach. But then some of the areas that we run into problems with large groups of people that are distributed, and Kevin has talked about this before, and you get the idea of mirrorology, or a part of. Essentially, there's some different interpretations of that. And so if we just use a natural language expression of part of, we're not really describing all of the logical interpretations of that. So in the Gellish ontology, talking about engineering, one of the simple examples was part of. But I think that Gellish ontology is a core piece that can be augmented with some of the work that Mary and I have done with, like the augmented model exchange isomorphism, which basically will associate not only a unique ID with every specific combination of a formal pattern, but will also associate the logical group combinations with those. So that starts to develop a core which starts to eliminate confusion. So it seems to me that this is really a good idea and a great concept, but do we have the available language to enforce it? Do we have the ability to communicate at that level of precision? And where I see a lot of the integration of models and so forth, where they have difficulty, is in the information loss in each form of language that's used. And so what kind of language do we need that either eliminates that information loss, or at least gives some type of way of bookkeeping for what they think that information loss would be. So I don't know if that makes any sense, but that's basically what I was thinking about the semantics portion.
It makes a whole lot of sense, and to me, it talks exactly to our point or our understanding of it. You talked about a number of points. So actually, the first thing I want to ask you is, how do you spell the ontology we're talking about?
Oh, GELLISH. It's an open source one. I just learned about it last week. I'll put it in the notes to the meeting.
Thank you. I have not heard of that. I will look it up. So you talk about enforcement, and you talk about communication, and particularly information loss. So in my experience, there's lots of anguish and deference and pushback on a large group level ontology or semantic agreement. Because everybody wants to do it their own way. Nobody wants to conform. They hate to have to be compliant. But you have to keep the end game in mind. You're trying to get to an integrated environment. And are you familiar with digital twin concept? It's kind of the holy grail of engineering or digital engineering. We're never going to get anywhere close to that if we don't have some kind of underlying foundation of an ontology, some kind of communication level. It can be a very complicated ontology, just like the English language is, with thousands of common usage terms and such. But without that commonality, we can't get there. We can't integrate our models. And I think what people miss in real application is that the fact that we all really do communicate with only roughly 1,000 words, and the rest of the words are embellishments on that or trying to improve on the communication, but you lose the bulk of your audience when you do that. So, but if you think about how natural language contracts and expands around those 1,000 words, you know what I'm talking about, right? The 1,000 base words of the English language.
Yes, I understand.
So my point is that within my community, if I can establish an ontology, then I can communicate within my community. If I want to integrate outside of that community, then I either need to be able to map my ontology to their ontology or something along those ways, and in order to affect that communication. When I just do mapping, when I just map between my defined terms and your defined terms, you being relative, I get that loss. That there's an inherent loss in that. If, on the other hand, I agree on a base set ontology, and I evolve my communication to use those ontological concepts in order to communicate, then I've, at the very least, reduced my communication loss as much as I can control it. Does that make sense?
Yeah, I think it does. But the way I'm viewing this now is I'm viewing it from the idea of, let's just go back to semantics, right? And right. So if we need to look at, we talk about models and executable models, then who's the interpreter, right? Do we have a human interpreter, or do we have a digital formal logic interpreter, right?
Right, but we're talking about model integration. The transformation to a digital model engineering environment is a computer-based digital environment. And that's an underlying thing. So to me, this semantics and ontology is a way to teach that computer our language.
So the important, I guess one of the important aspects here then, in my mind, is the idea of semantics in a formal logic a construct, and the idea of semantics in human language. So human language, humans, like to talk about the 1,000 words, we get semantics from context. So we have, if we as human beings have sufficient common context, we can communicate using nonsense syllables because we all understand what those signs mean. So within the formal logic standpoint, we go to executable models. We're into syntax and types of operational procedures, which then represent the semantics to the machine. And so the integration of these two completely different interpreter types is challenging. And so one of the things I thought was really cool about Gellish was its natural language independent. And so you can, if they just take patterns and you can plug in English, French, German, whatever, put it in there. And so you're getting some of these fundamental patterns which can be executable with a machine, but depending upon the context, what the natural language is for your human group, you can have the proper natural language in it. So I think there's a lot of potential there, and but that disconnect between the interpreters, because we have human interpreters, we have machine interpreters involved, to me it makes it, you know, the getting the essential information out very, very challenging.
I would agree entirely with that. Now I will read about this twice, because you said something that strikes me as interesting. I'm not sure how you teach a computer context, and B, how it could be natural language independent. Strikes me as an oxymoron.
Oh, okay. So I guess it just seemed to me like if A is part of B, right? I can do that sentence in English, Spanish, German, Italian.
But you're in each of those languages. So I speak a little bit of each of those languages, and there are many ways to translate a single language type. Usually, literal translation often misses the actual point of a context. For example, trying to translate a poem.
Exactly. So okay, so now we're in the realm of, and so that's what I'm saying about Gellish, right? So if you're going to do that with Gellish, right, what you need to do is you need to augment their form that they have now with the logical group types from the augmented model exchange isomorphism, and that augmentation then matched to the natural language form gives you that extra logical information that's not in the Gellish form now. But yeah, so that's exactly correct. It's an interesting conversation, actually.
It's not germane to the conversation here, though. But we're not. Fortunately, I guess I would say the computers are not at the level of understanding that the human mind is quite yet, and so until they do, we have to conform our thinking to a subset, which is the semantic underline or the ontology. But I would submit that you're talking about augmenting the semantic model of Gellish, and I'm not sure how you get that, the way you pronounce it, out of L-O-I-S-H, but my point is that aren't we simply enlarging the ontology then by adding the augmentation to it so that you can define more context? I mean, that's all you do. If you restrict your ontology even for a computer modeling environment in exchange to a few words, you're only going to get a few things. If you can embellish that to a much larger set of terms, then you have much more context within your with your interface, within your integration.
Right, and so also Gellish, it's also like a taxonomy, but It integrates the two concepts of an ontology and a taxonomy. But the idea here is like not necessarily about like A as part of B. We're not talking about A and B. We're talking about the relationship itself.
Right.
And so we're talking about the ability to more clearly refine the logical properties of part of it.
Cool.
And so then that's the idea there.
And the spelling of that language is Gellish. That help?
Any other questions?
Yes, Ed, so did you in your group talk about the pragmatics of language in addition to syntax and semantics?
So this is all about engineering modeling context. And so everything we talked about was in that paradigm. It was not a conversation about language, about semantics only. This was, so I don't think we went to where I think you're heading.
Well, if you're interested in analyzing the nature of communication using language so that you want to identify the invariants, you should look at, at a minimum, syntax, semantics, and pragmatics as a three-part distinction. I think syntax is usually, in linguistics, syntax is not taken as one of the three fields in itself. There's morphogenesis and things like that. But pragmatics has to do with how a signal is interpreted into an action, which is really what you're after with your number one there, the information is the signal is just an artifact until you have an interpreter that acts on it. And so going from the signal to the action involves mapping to semantics, but it also involves the context. As Joe has mentioned a few times, the word context is very important because the same signal in different contexts will and should produce different actions, and it's the appropriate action is what you're really interested in.
Yes. It's we're looking for interpretation of correct interpretation of the signal, which is what you're saying has context around a particular term or something. Which is why I refer to an ontology. To me, that's what an ontology is, as opposed to a taxonomy.
Right.
And then
that's very tricky.
Semantic expands beyond that.
That's what is. You said that there is or there should be a consistent stable ontology. Now that's in that phrase is or should be. There are a lot of issues right in that question of there isn't. Why isn't there? What would it take? So an ontology arguably could provide that, but at this point it's not, and that's a really interesting way of approaching this. That would be an interesting topic for a System Summit agenda or for another conversation.
Do you know Steve Jenkins?
No.
From JPL. So I would encourage you to meet him. He will spend far more than a single week talking exactly this topic and concept. That is his world and realm.
Right.
But so I can tell you where this is coming from. If you, without talking about anybody's age here than my own, back in the 80s and 90s, there was this concept of a corporate data model. And embodiment of it ended up being this guy. I was at Boeing back then, who lived in this office that had no windows, and he literally papered all his walls and ceiling with contextual diagrams of entities and relationships. And he kind of lived in that little cave and data modeled him for his entire time that I was with the firm at that point, creating this corporate data model, and nobody ever heard anything out of it. He never came out of his closet that we were aware of. So that's one embodiment of why this is difficult, because it's hard to come up with agreement from everybody of what that invariant semantic model is, because everybody wants to add their own little word definition, and people don't want to be constrained to a certain set of terms and words and things. I still do some engineering modeling now, and I'm in the middle of a thing right now, and I'm going through a bunch of requirements, and I'm thinking, well, these are all constraints. And it's the same kind of thing. The particular modeler that I use that is leading this effort called these things requirements. She didn't call them constraints. And so I'm wondering just how far do we go, or do we have to, how to implement this is, as you say, a very difficult thing, which is why it's not done. It's people don't like the constraints, don't like how you define that term versus how I define that term, and that kind of thing.
Right, and the
Welcome back, Peter.
Yeah, the ontology standardization efforts seem to be very primitive. There's a lot of good ontology development locally, like Matthew West developed a really good 4D ontology that's used at Shell that has time as a fourth dimension of space, effectively. So it's very rigorous.
That's at Shell? Shell,
yeah,
the
Shell.
oil company?
Yes,
okay.
Yeah. Matthew West is his name. But if you look at, for example, there's a current ISO proposal on top-level ontologies that's 21838, and it's quite inadequate for the kinds of things you're talking about. You know, this kind of vision.
Right. The DoD, the Navy, also each of the services have their own too, and they're trying to define. There's another effort going on right now to try to define a Navy-wide ontology and stuff, and they always seem to fail. I'm thinking because the group is too big. It's hard enough for me to try to get Sandia, a 12,000 person organization, to agree to a consistent ontology, let alone the 3 million people in the services. You either make it so big that you can do anything and you might as well not have an ontology, or you make it so constrained that you can't communicate.
Right, or you make it so robust and evolvable and customizable that you anticipate the needs of the 3 million, but the group that develops it is small enough that you can, you don't have to get everybody on board at the core.
And of course, the moment your group picks your own set of terms for your communication inside your group, you have trouble communicating with those outside of your group, right?
That's right.
So there have to be, so we the industry need to evolve how we do all this. What kind of rules do we have for that internal customization versus external communication and termination? What kind of tools do we have for that? How do we map that to somebody else's? How do we make this easy and ubiquitous and acceptable? We haven't crossed that bridge yet very well.
I think one of the big problems is that this is not understood to be a, a national grand challenge. That when governments or industry groups or whatever think of grand challenges, they think of new energy sources or
Right.
things like that. Whereas this, I see this as the fundamental grand challenge. That if we could get more coherence in this area, then we could address the other challenges, which are all specific challenges. But this is the one that without without an infusion of urgency and resources, like a ARPA kind of project or a Manhattan Project, all you have is different groups coming together locally for their own standardization. And as you say, that even increases the distance between them once they have gotten more, focused on particular terminology for themselves. So I just don't see anybody on the national level, let alone international, saying that this is the biggest challenge we face, is the failure to find coherent ways to have more informative artifacts, to have evolvable systems, communicate across stakeholders and all those things. It's been known for decades, but it's not there. It's not. It doesn't have a particular powerful stakeholder group pushing this. There's usually, as even with the branches of the services, it's crazy that the services can't. If they can't communicate, then what are we hoping for? With trying to get different commercial interests to agree.
So I have an anecdote for you there on that. I don't know if you're familiar with the efforts between the Air Force and the Navy for joint various systems, joint fighters, joint strike, joint missile defense, and systems like that. Every time they come up with the new system platform, the DoD wants a joint solution because they think it'll save money and cost. And and of course, we have that same situation. And within my world, there's a system that we've been planning and thinking and all this kind of stuff for years about a joint solution. My anecdote is that, well, it's easy. We'll have a joint XXX as soon as the Air Force accepts the Navy system.
Right. Right. That's right.
So we've spent a lot of time around the term semantics. We haven't spent any time around the term independent of the other information formats, structures, and that kind of stuff. I'm not sure if that changes any of this conversation. Does it? It's the concept of the independent information contained in the model versus the invariant semantic underlying. Does that still hold water?
Well, I think so. I think the independent part, is important. And if we look at just some of the fundamental capabilities of the two interpreter types we're talking about here, one is machine and the other is human being, then essentially machines can actually deal with the type of information that humans cannot. They can do extremely large sets of logical operations. Humans just can't do that. There's no way for them to do it without a machine.
We do it, though. We do it, but we don't keep track of it well. I would contend that what machines do better is they don't do complexity better than we do. They keep track of complexity better than the human mind does. But if you think about all the different concepts in your own mind and topics and things that you have some level of knowledge on, that's far vaster than any computer.
The human beings have a capability that's far beyond computers. So I agree that there's things that computers can do better than human beings, and there are things that human beings can do better than computers. And so that kind of starts a functional independence category.
Right.
And so we usually assign tasks to computers that humans can't do well, and we assign tasks to humans that computers can't do well.
Yes, actually, that goes to the very root of the why, or the paradigm shift towards model-based engineering. Is what we're trying to do is we're trying to optimize the computer to do the things the computer does well, and extract the human to doing the things that the human does well. The context, the contextual things, and understanding that information. But let the computer do the things like analyzing that data for completeness and omissions and traceabilities, and counting the variables and keeping track of all the very links and that kind of stuff through a complex design model.
Yeah, so those are, but for the idea of independence, I think then that we have, that starts to naturally make the sources of the information and the understanding of the information into independent categories.
Well, that's why it's important, because that's where the human mind circles. The human mind circles around all that information, and the contextual information and understanding of it. Why is X more important than Y? Or at least defining those criteria, as opposed to the computer trying to identify that criteria, because it's only going to identify it based on what the human mind has programmed into it today.
Yeah, so we have about 3 minutes left. This is a very interesting conversation. We usually have a middle of every 2-week session. And so I guess what we need to do now is decide what we want to do for the 18th, 2 weeks out. Do we want to continue along these lines, or do we want to do something else?
I think we could talk about the implications of model-based engineering with respect to structural modeling.
Okay.
I mean, just as an open discussion, I think would be valuable.
So are you referring to the transformation from structural modeling to model-based modeling? To digital modeling, or I'm not sure I understand the context.
Well, structural modeling has been used to create models for decades.
He's talking about
mental models, paper models, all those things.
It's basic area of the dependency structure matrix methods. Would you say that that's sort of the core of it, Kevin? John Warfield's work is what we're particularly trying to advance. Yeah, but there's so many. There's behavioral system models and structural system models is the key distinction we're working from, and the structural methods. So Friedman's constraint methods and various different people have developed the dependency structure matrices methods. And then within that, as Joe alluded to, one looks for the ability to go from natural language to diagrams to mathematical models and back again. So those are the model exchange isomorphisms that allow for group modeling.
And the structural...
Yeah, go ahead.
The structural modeling, the mathematics can model most any of the relationships that are in any modeling language, object-oriented, UML, that type of thing. So, but there's also implications of what your manifesto says. For example, reuse over creation, and that's an interesting discussion of how often are models reused within ISM? There's procedures for amending existing models within ISM, but they don't get published very much because they're not as sexy as doing a whole new model from scratch for publishing purposes.
Right.
And so I think there's a number of interesting discussions to be had about the relationship.
Right. So, and the system dynamics world is focused on the behavior. Well, they do some structural modeling, but they're primarily focused on the behavioral side. And so the structural side does not get the respect and attention that it needs, we think. If you're to have a model that actually has valuable information, and it's not just an artifact. So yes, I agree, Kevin. I think the discussion of the implications, I think in both directions, both what can the structural modeling perspective bring to MBE and vice versa. So we're available for that. So Ed, my husband Michael here is also always listening. He worked at JPL in the 80s, and we just use one device so that we don't have audio feedback because we're usually on the road somewhere inconvenient. Say hi, Michael.
Hello, all.
All right, so I think we've got a topic for April 18th, and I'll try to summarize, send out to the list, and also attach these 3 charts. And thanks, Ed, for presenting this. It's very interesting.
Yes.
And like I said, I think it's kind of a core piece where we can kind of look at it and see if there's places that other concepts attach well, or maybe we'll need some modification before things match up better.
Do you want to bring this back in the conversation on the 18th?
Sounds good to me. Sounds great. Yes, I would like to.
So, and then zero in on the structural versus digital model paradigm.
Right.
So,
Talk about the function of those. Like,
Right.
The primary focus of structural modeling is to how does an extremely large group of people identify an unknown problem. It has an unknown structure. You don't know what it is. So how do you start defining these very large-scale unknown problems? And usually, these problems are beyond the scope and understanding of 1 or 2 human beings.
Right.
So those are the types of things. Okay.
Which I would agree. And actually, some of that is embodied in what our thinking in our conversation on some of this. I come from a structured analysis background.
Excellent. Okay. Well, with that, I think we'll stop the broadcast now and sign off and talk with everyone on the 18th. Thanks, Ed.
All right. Thank you, everybody. It was fun.
Okay, bye-bye.
Bye-bye. Thank you.
Bye. Thanks.